So we're going to look at different color balls here, and we've got a bag here that contains, we've got, let's get the right color, bag has one green, two red, two blue, and one yellow. So that means there's 6 balls altogether. What we're going to do is we're going to work out the probability of getting different colors if we take one after another for taking 2 balls. And we'll do it without replacement. So no replacement. So we could go through and work out the probability of, say, green followed by red, plus the probability of red followed by green, plus the probability of red followed by yellow, etc., etc., etc. But of course, there's another way of doing it, and that is to say that this probability equals 1 minus the probability of 2 colors the same. Okay, 2 colors the same. So what we're going to do now is look at finding the probability of 2 colors the same. So let's have a look at the probability of red followed by red. And we know there's 6 balls altogether, and there's 2 red to begin with, so it's going to be 2 over 6 for the first red. The second red is going to be, well, there's only 1 left, and there's 5 balls left altogether, so 1 out of 5. So we get 2 out of 30, which equals 1 out of 15. Now we can't get 2 greens, and we can't get 2 yellows, because there's only 1 of each. About the 2 blues there, we can get 2 blues. Let's have a look at the probability of 2 blues. Again, it's going to be 2 out of 6 for the first blue. And then when that's gone, there's going to be 5 left and 1 blue, so 1 out of 5. It's the same thing, isn't it? 2 out of 30, 1 out of 15. So the probability of different colors equals 1 minus the probability of the same color, which we said before, same. And that's going to be 1 minus these 2 added together. Well, 1 over 15 plus 1 over 15 is 2 over 15. And we subtract that from 1, we get 13 over 15, which equals, as a decimal, 0.87. 0.87, which is about 87%. So we're selecting 2 cards. We're going to select an ace followed by a king. So we know that there's 52 cards in a deck. 52 cards. And the probability of drawing an ace, first of all, equals 4 out of 52. And now we know there's no replacement, so we now there's drawing a king next will be 4 out of 51, because there's 51 cards there. So the probability of an ace and a king equals 4 over 52 times 4 over 51, which equals 16 over 2652, which equals 0.006, which equals 0.6%. So rolling 2 dice, let's say we're going to make a sum of 5. So we're going to find the probability of getting a sum of 5. We know that 5 could be a 3 and a 2, a 2 and a 3, a 4 and a 1, a 1 and a 4. So therefore the probability sum of 5 equals 4 divided by 36 altogether, So 1 over 9, which equals 11.1%. So let's say we've got a shipment of 11 microwaves. And we know that 3 are deficient. We've got to find the probability of selecting 2 of them and 1 being deficient. Well, not deficient, defective, isn't it? 1 defective. So the probability of 1 good and 1 defective. So the probability of 1 good is going to be, we know there's 3 defective, and therefore 8 must be good. So this is going to be 8, choose 1 for the good ones. That's the good ones. And then the bad ones is going to be 3, choose 1, all over. We're only choosing 2 out of the 11, so it's going to be 11, choose 2. So 8, choose 1 is 8, 3, choose 1 is 3, 11, choose 2 is 55, and therefore we get 24 over 55, which equals 43.6%, or 0.436. Poker here, we've got to find the probability of 2 aces plus 2 twos. So we know that the aces is going to be 4, choose 2. The twos are also going to be 4, choose 2. Now the last card could be anything. So there's 52 minus 4 minus another 4 leaves us 44 cards left, and it could be any card. All divided by 52, choose 5. And that equals 6. 4 choose 2 is 6. 4 choose 6 is 2 is 6. And then 44 divided by 52, choose 5. And that equals 0.006, which equals 0.06%.